In Experiment 4, we'll build a voltage divider controlled car as well as learn more about the generation and measurement of time-varying signals. Your cloud detector pre-lab is just one example of a circuit with voltages that change over time. In the initial breakout period, we want you to work with your lab mates to construct an array of cloud sensors that behave in a consistent manner. This may require changes in LED color and in potentiometer settings. When finished, measure the resistance of your potentiometer on the ohm meter. Compare your value to others. Although not in the procedures, you may also be interested to find out the resistance of your photoresistor when illuminated and when shaded. We'll use the oscilloscope to view time-varying signals like those produced by your cloud detector. Connect channel 1 of your oscilloscope between the negative rail of your circuit and pin 2 of your Schmitt trigger IC. Connect channel 2 to pin 1 of the IC. Always begin by pressing the default setup button near the upper right side of the scope. Now press the number 2 to turn on channel 2. The horizontal axis knob will allow you to zoom in or out on the time axis. Zoom out to about 1 second per division. Adjust the trigger setting to 2 volts. You can adjust the vertical axis of channel 1 to make this easier. Press the single sweep button on the upper right of your scope, then shadow your cloud detector circuit to collect a block of time-varying voltage signal. You can use the horizontal axis adjustment to zoom in and see that the scope gathered data before and after the voltage crossed the 2-volt trigger setting. We will now return to the car and build a motor drive circuit that uses a MOSFET transistor to separate the higher power function of driving the motor from the lower power voltage divider that sets the speed. Locate the MOSFET in your electronics kit and note the wide leads. These can damage your breadboard if forced into it. Instead, we will gently bend the gate lead back and the source lead forward so that the MOSFET can be safely inserted without overspreading the metallic clips within the breadboard. Now build the voltage divider based motor drive circuit onto your breadboard. Connect power to your circuit and verify that the potentiometer can be used to control wheel speed. Use your voltmeter to determine the voltage at the gate of the MOSFET when the wheel just stops or when the wheel seems to first hit full speed. The function generator is a benchtop tool that can generate periodic signals. It behaves like a time-varying voltage source, but by design it has a 50 ohm internal series resistance. This 50 ohm resistance will act as 1/2 of a voltage divider when a load resistance is connected. The default mode of the function generator is to assume that a 50 ohm load will be attached. Therefore, the amplitude readout will only be 1/2 of the actual peak-to-peak voltage generated. This can be verified by attaching a cable from the output port of the function generator to channel 1 of the oscilloscope. Again, start from the default setting and adjust the vertical and horizontal axis until you can see the signal. The measure button on the scope will allow you to view the peak-to-peak voltage. The default setup, channel 1 looks like a 1 mega ohm resistor, but it can also be changed to 50 ohms. When the oscilloscope and the function generator are both set to 50 ohm mode, then the two peak-to-peak voltage readouts will agree with each other. This is also true if the oscilloscope is set to its 1 mega ohm load and the function generator is set to high Z. To shift between modes on the function generator, hit Shift-Enter followed by 3 right arrows, 2 down arrows, and then one more right arrow to actually change the mode. Press Enter when finished. Enjoy your Explore More modules today and take advantage of the breakout session to learn more from your classmates.